This question says, given a parabola with vertex at 0, 0 and focus at 0, 2, construct the equation, determine the directrix, and construct the graph. So let's look at those 2 points, the vertex and the focus, and then we will do the rest. So I'm going to go to Desmos so that we can see those points. So we have a vertex at 0, 0. That's our simplest case. And we have our focus at 0, 2. So the parabola always engulfs the focus. It's going to go like this around the focus. The focus is in a sense in the interior of the parabola. That's a way for us to think about it. And again, there are 4 different cases we can have for parabolas. We can have x squared equals 4py, where p is positive. When that happens, it looks like this. X squared equals 4py, where p is negative, and it looks like this. Then we have y squared equals 4px, where p is positive, it looks like this. And y squared equals 4px, where p is negative, and it looks like this. So those are our 4 cases. And we said that the parabola engulfs the focus, so this will be our case. It will be x squared equals 4py, where p is positive. Let's go back and take a look at our picture. So it's heading that way. The distance that we have from the vertex to the focus is 2, so p is 2. So my equation should be x squared equals 4 times 2, x squared equals 4py, so 4 times 2 times y. That's what we get. That should be our graph. Again, engulfing it, p is the distance from the vertex to the focus. P is positive if you go up, p is negative if you go down in this case. Now, what about the directrix? The parabola is the set of points equidistant from the focus and the directrix. So if this is halfway between this and this, so the directrix is coming down here. The directrix is going through -2. The directrix will be y equals -2. And that's our directrix. Not sure what happened there. So set of points equidistant, and you can also find a couple points on the graph. Now, how do you do that? The distance here is 2. So if I go twice that is 4. So if I go 4 units up from this, 4 units over from that, I will get this point here, which is at 4, 2. Should be, well, I guess I have to write it down here. 4, 2, we see that point, and the point -4, 2. I want you to take a look at the distance from the focus, 1, 2, 3, 4, from the directrix, 1, 2, 3, 4. From the focus, 1, 2, 3, 4, from the directrix, 1, 2, 3, 4. So those are 2 points you can find on the graph to help you actually construct it. And if you're interested, that line between those 2 points is called the lattice rectum. In this case, it would be y equals 2 as we range from -4, less than x, less than 4. So that's a way to get a couple points on the graph. But again, the parabola is the set of points equidistant from the vertex and the from the focus and the directrix. The vertex, 2 units from the focus, 2 units from the directrix. This point on the lattice rectum, 4 units from the focus, 4 units from the directrix, which is known as double P, 2 times P. 2 times P is 4. So 4 units this way, 2 times P, 4 units that way is how we find the points on the lattice rectum. So we have our equation. We have our directrix equation. Y equals -2 is the directrix. And of course, we have our graph of that as well.